Okay, I think we can get started. I'll head the stage, I guess, to Dorivar, since we already started and presented him last session, which was yesterday. So I think everyone was here. And I'll let Dr. Ruiz Diaz continue with the SAS workshop.
Thank you, Josefina. Thanks for being back in the second day. One thing that I realized yesterday is that most of you use SAS Studio, and I think that's a challenge. I was showing basically the desktop version, which is what I use. Honestly, I never used the SAS Studio version, and so. But what I'd like to do quickly today is go through that again. Just today, I open SAS Studio and I play with that a little bit, and it seems to be pretty similar, pretty straightforward. But there are some differences, and the main difference is that it is a web-based, 100% web-based, and so that makes some things different. And so I'll go through that again and just make sure everybody's able to upload their data and run the same analysis we did yesterday using SAS Studio. And I don't know if we can do a poll here. I'm just curious to see how many of you have the desktop version versus which is the enterprise versus the SAS Studio. See if we can do. I don't know how to do the poll here, but maybe what do anyone want to comment here? Is any of you using the enterprise version?
I have the regular, just desktop version of SAS.
Okay.
So.
Which is the one that I was using yesterday?
Yes.
Okay. Okay, Logan says SAS Studio. SAS Studio. Most people seem to have SAS Studio. Okay. Okay, so that's good. It is okay. Again, like I said, this lack of communication, I didn't realize that we should have just worked with SAS Studio. It's not really a big difference, but let me go through that quickly, and maybe we'll just complete the day today just working with SAS Studio just to make most people comfortable with that. I see a few, maybe 2 or 3 people as the desktop version. I usually have my students get the desktop version. It's just easier. You don't have to be online or anything to use that, and it's a little bit easier. And so as a graduate student, I would suggest you get the desktop version, the enterprise. I guess it is I think it's $120 per year, but your advisor should be able to cover that. It's not, it's part of your research, and so I will encourage you to look into that. I think it has a little bit more flexibility, and from what I know, there are also some things. The studio version is basically a student version, and there are some functionality that maybe is limited. And so I'll definitely encourage you, if you especially if your advisor is asking you to use SAS, then ask him or her to pay the $120. Again, it's not much for 1 year. If they say something, tell them that I told you to to ask for $120 to pay for the software. They can complain to me. Okay, so let me share my screen. Can you see? Let's see. Can you see my screen here? Okay, so these are just my folder here where you're seeing a few files, and I have the SAS Studio web version. Now Okay. Let's just oh, here we are. Okay, so essentially this is what you have, and or most of you have. I just made one folder. One thing that I mentioned yesterday, I talk a lot about the desktop version here with many libraries and folders, and I see the same thing basically in Sas Studio. I made one folder here. I call it Workshop Spring 2022, where I'll just put some of the files. And again, it's just basically uploading the files, choose the files, go to my folder here in my computer. And I'm going to start with the one that we did yesterday, which is the soybean potassium with the actual data, and upload. And so it's there. It's the same thing, again, the same file that we run yesterday. Everything looks okay here. And again, this is just a proc. Just the proc univariate, and the results. Again, this is something that we did yesterday with the desktop version as well. Exact same thing. I don't see any difference there. So those of you who mentioned I had Sas Studio yesterday, sounds like you were able to do this already. I know Logan for sure, maybe Brian and others as well. But again, I feel like maybe a few people were not able to do this, and just wanted to go through that and make sure everybody's able to do it. Okay. Okay, so any questions there? Anything on this? Again, same thing, the code log, same type of information we got from yesterday, and then the results. Actually, the data as well is included here, the output data. It's actually maybe provide a little bit more detail, more information in the output. Any questions on this? Okay, so just gonna leave that there. Do the same for the other data that the other file that we used yesterday with the Excel version. And so first I will upload and this may be many ways to do it. And I know Logan mentioned a few other things yesterday already. Again, it's the first time I opened it today. And so I did it the way I was kind of what I find out how to do it. And so I put the Excel there. Now we have the Excel in this folder right here. I'm also going to upload the actual file, and I call it version 2. I make one change, obviously, because of the way we importing the data now. That's going to be different. And I'll show that in a minute. Upload that as well. Okay, so one of the things is, so here's the code. And again, this is the same code that we have yesterday. The only difference is that I'm making a change in terms of the initial import, because we are not using the desktop version. Okay, and so what I'm going to do in this case, since we still have an Excel, I'm going to go ahead and convert this into a Sas data format. And so I found here that you can basically import the data. If you go to Task and Utilities, you can import the data and convert essentially to Sas data format. Select the file in our folder. use of Excel. See the extension there. Open. And we can change the name, the data set. Now it's going to be a data set. Okay. So by default, I guess it's putting import. I'll change that to all data, which is what we will. I think that's what we used yesterday. Everything else looks okay. And actually generating some of the code that's used in SAS to import and convert the data, which basically use a prog import. Okay, so this prog import is something that you can essentially you can code, but the tool here is basically generating that automatically. I think I already have one there. I'm just going to replace it. Everything looks okay. And if we go to the libraries, and again, this is the equivalent to what I showed you yesterday, where we have different libraries. We have the work folder, which is the temporary folder that SAS going to use for the data. And so here it is, all data. Okay, everything looks okay. Close that. Let's close the import function. I don't want to save it. I guess we can save it if we want, but see the need for that. And so yesterday we have show you we use the dynamic data exchange to bring the data from Excel. Obviously this works okay with the desktop version. Right now what I show you in the studio version, we already have the data, all data in the work folder. So we don't need to import anything. It's already there, okay? That's basically the step we did just previously. Now, one thing that I add here, so we can go straight from here, we can go straight and do the analysis that we already have yesterday. But one thing that I showed you yesterday is to make changes, for example, adding new variables or deleting variables, or and so what I did is I basically generate a new data. I call it all data one, and basically we do that with the set function. And so we set the all data, which is data we have already. We're going to generate a new one, and in this case we can do the same kind of changes we did yesterday. Can generate a new variable, delete some variables, and so on. So just to show you that, I'll again highlight from and the new data here. It has the k-rate square, which is the new variable we generated. And again, we deleted two of the locations, which is no longer here. So this new data set, again, it has the modification. We call it all data one in this case. Okay, just to show you that the set function is one function that can allow you to generate new data sets and make changes to that original data set. Basically anything you want, just like what we did yesterday. So just wanted to show you that. Okay, everything else, again, if we go back to what we did yesterday, proc sort, sort the data, give you the output, proc univariate, same thing. Okay. And then we pretty much stopped yesterday at the progly mix. We did run some of these. I'm just quickly gonna run this again and get into some of the output. Any questions so far on this SAS Studio? I'm not an expert on these. So like I said, I just first time use it today, but everything seems to be very similar. It's just a few things that are different where things are located and things like that. And from what I understand, also there are some limitations perhaps in functionality in some cases. And I don't know if some of you using SAS Studio, do you have any issues in the past with limitations in functionality that you'd like to comment?
Not necessarily. I haven't had any issues with the work that I have needed to do in SAS Studio. The biggest advantage for SAS Studio is I usually have access to internet, even if I'm not on campus. And so it does allow me to continue working on things, even if I'm not right at our computer that has the desktop version. So that's my biggest advantage there. I haven't had much limitations so far.
Sounds good. Thanks for sharing that. Anyone else? So that's good. And one of the things, and again, I'm not too familiar. I don't know what this means when you graduate, or how that may affect. It seems to be again more of a student version. And when I signed in today, it was pretty straightforward. So I didn't. It seems to be essentially free. And so if it is something that you can use even in the future, it's actually a good thing. Hopefully it will stay that way. And I was glad to see that, because I think this is one of the challenges with SAS. Obviously, R is free, and that obviously similar or even more capabilities in some cases, and so that affecting the use of SAS more and more. And so I'm glad to see that there's a way to have access, hopefully in some way, hopefully free, at least in this version. Okay. So yesterday we ran the progly mix. I'll run this again here. The same output that we saw yesterday already. We went through some of the outputs, the p-values of the fixed effects, the LS means, estimates, standard error, and the separation using letters, right? So we went through all of that yesterday. This is analysis by location. I see that there's some things here in terms of being able to download the output as a HTML, which is good. So you can essentially save this in your folder and maybe run many analyses and look at it later. And so you have all of those functionalities in SAS Studio, which again is good. And so yesterday we did the analysis by location, and then we basically, I think, stopped at this point where we also basically did an analysis across locations and using location as random as well. Okay. And this is similar output. In this case, now we have one of the additional class variables that we have here is location. We have four locations, and these are the names of the locations here. Similar fit statistics, all of this, we saw that yesterday. One of the things I added here is that I added this at the end of the lines. We added the alpha equals 0.05. 0.5. So this should be 0.45. And what this basically does, once you put the alpha, we basically get in also the confidence interval, okay? Using 0.05 in this case, the same estimates, which is the LS means for the treatments. And we have the lower and upper brackets, okay? So if you're doing your graphs, you want to put confidence intervals, 95%, whatever confidence interval you want to use, then you can do that pretty easily here using the alpha, with basically the number that the option that gives you that output. There's also, I added another option here, which is the pdiff, basically looking at all the difference between the treatments. And that's this table here. And so you see differences between the treatment 0 and 56, and it gives you the difference. So this estimate now is the difference between these two estimates, okay? Same thing, you have the standard error and confidence interval using the alpha level that you choose. And the T group, which is again the same thing that we showed earlier. Remember, this is across all locations now. And so what we see here is that the treatment here, the control, the check is has a C, which is different from A and B. So it's statistically different at alpha of 0.05. Okay. So again, this is one of the tables. Is very often, I know many colleagues, maybe some of your advisors will always ask for a quick ANOVA table or a table with the letters to indicate mean separation. And this is basically the way to get it pretty easy. Any questions or comments so far on this? Okay, so let me stop there, and I have other code here that has some graphs and some other statistics that we can do. But yesterday we did have some questions on LS means and I think different types of models. And I wanted just to go back and touch a little bit that concept, because I think it's very important. And so what I did is I put together this table, which is basically just fake data that I put together just to make it simple. Basically 2 treatments, 4 replications, and 2 locations. Okay. So typically, if you're going to do an average or mean value for treatment number 1 across the 2 locations, you'll basically do an average of these 8 values, right? And so basically we'll be adding all of those values divided by A, which give you 4.63, right? So it's basically what I have here in Excel. I also use the average function in Excel, which is there, give you the same value, okay? Now, what happened with LS means? LS means basically essentially bringing your model component and giving equal weights, in this case, to factors like location, okay? So what happened in this case is first, we do an average of location 1 across those replications for treatment number 1. And then we do an average of location number 2 across all the replications. And then we do an average of these 2 values, okay? Essentially what you're seeing here, adding all the values divided by 4 for treatment number 1, they give you 3.0. Adding all the values in location number 2 divided by 4 give you the average of 625, right? And now we take these 2 averages, 3.0 and 625, and that's divided by 2, and it gives you 4.63, right? Okay, so yesterday the question was what happened if we have missing values, and as you can see, these 2 numbers are identical with a situation where we have no missing value, everything is the same, right? Same thing here, just for treatment number 2, the same steps. Any questions on these so far? Okay, thumbs up so far following. Okay, let's delete here. We have a missing value. Delete this number here. Now we have different numbers. Okay, and you see what happened with means is that the number, the calculation here, basically significantly lower because we have that missing value. Obviously, in this case, because we are dividing by A. But even if we use the average function in Excel, the value is significantly lower than what you're gonna get with LS means. And what happened here is because, as you can see, the average in location number 2 is higher. In general, this was a 6 here. And basically what we're doing by doing an average of an average in this case, we're giving equal weights to the 2 locations, okay? We're not penalizing essentially location number 2. If we're not doing LS means, we're essentially penalizing location number 2 just because we miss one value there, okay? So for whatever reason, we lost one soil sample or we missed one plot in location number 2, suddenly the overall mean is significantly lower, when in reality, if we did have that value in location number 2, that number should be higher, okay? And so that's essentially what we have in how means and LS means are different. And that's always the challenge, and oftentimes I think we need to explain that. I know oftentimes people do the calculation in Excel and say, well, I'm not getting the same value, why SAS is different. And this is essentially what's happening, okay? So just wanted to revisit that concept and make sure that's clear, and why we should be using, especially in situations where we have missing values, we should be using LS mean rather than the means. And again, if we have a completely perfect study, which not often happens in agronomy, you know, obviously there's no difference, so who cares, doesn't matter. But if we start to see some of those unbalanced missing value, then we have an issue. Any questions on this? Okay.
I have a follow-up question, and this may be something that is kind of outside the scope of what we're talking about today. So I did go back and check some of my data before I came in to the meeting to kind of follow up on this question. And yeah, so like the LS means and the means that in Excel were giving me completely different, or not completely different, but slightly different values when I had missing data. But when I'm looking at two-way like interactions in my model statement, and I have my whole, like the data set is complete, I was still getting different different values for my interactions. My main effects were the same, and I didn't really know what's the cause of that.
Yeah, it's essentially the same thing. There's going to be slight differences here in interactions, and the reason for that is because we are doing this average of average depending on the, again, these are going to be factors. In this case, I put locations, but you can have another factor, fixed factor, right? It could be treatment number 1 is potassium by nitrogen again. And again, and then you can have locations, you can have multiple locations, multiple interactions, and you'll keep doing this average of average, and oftentimes it's going to be slightly different. And so that's one possibility. The other thing is that the way SAS is calculating, especially using green mix, restricted maximum likelihood, things start to, the ways calculating SAS is it start to get more complex, especially if you have random factors, because it's based on probability, and that again goes back to the restricted maximum likelihood calculation, and so that may have an effect as well. But often with very complex interactions, you start to see slight differences in these values, not very big. But when you have missing values, those differences can be pretty significant.
Thank you.
This is a good question, and again, I often see these from many people, so it's important to clarify and explain this to committee members. I often see this in committee member defense come at this question, and I think it's just maybe something that we need to understand and explain. Okay, very good. Okay, so what else we have here? Different methods and different analysis. I'll share with you here another analysis in a minute. One thing that I wanted to finish this first. There are other things that we can do in Gleanmix, especially when it comes to graphics. One of those options is using the ODS option, and ODS actually give you something that give you a lot of options in terms of generating PDFs and Word and Excel, but graphics is one of those. And so if you put essentially ODS graphics on ahead of your code and ODS graphics off at the end, the beginning at the end, run the same code, get a lot more information. These are all the same. We're just looking earlier. P-values, LS means, but we start to get some figures, and again, especially we are asking for all plots. So just here, you can specify what kind of plots you want. I often just put all plots and basically give you all the plot requested that are relevant for the analysis, which is just kind of nice. So you can get it. You can look at those plots. This is the tissue potassium LS mean values by different rates. We can also do comparisons against the control, and in this case, in the code here, specifically in this div, compared to the control, we are requesting that. Okay. So in this case, this is the confidence interval for the control. The mean value for the control is 1.99, and anything that is outside of the confidence interval, obviously, is statistically significant difference. Okay, and so this is the comparing to the 56, 112, 168. So that's the other thing to keep in mind, and kind of how to interpret 95% confidence limits. Usually, if you're comparing two means, and if the values are the means of one treatment is outside of the 95% confidence interval of the other one, then those are statistically significant differences. This is one graph. Also give you graphs in terms of just how the models fit, residual plots, distribution, quartiles. Again, all of this just an indication of how the model is performing, which again, I don't see any issues. Usually we want to see kind of a uniform distribution here, bell shape, good distribution, and this basically following the line. And so our model basically is working okay. No big concerns in this case. Okay, any questions so far on any of these? Okay, so assuming everybody was able to run Sas Studio this time, no issues. Again, I feel like yesterday, maybe there were some people who were not able to upload and run the code and that kind of thing. So I worry a little bit about that. Okay, so I'll switch and look at other data. I'll just stay here with SAS Studio. I think I'm just going to delete this, just empty this folder. And I'll share with you a few other, just a couple other files here in the chat. Okay, so yesterday there were questions about different types of models and different type of data, and so I wanted to share with you one that is not normally distributed data. And so this is this data set has colony forming units, bacteria. It's just different soil types, days of incubation, texture, and a few different treatments here in replications. Okay, so it's obviously this kind of data tends to be messy. I mentioned yesterday things like runoff, N2O emissions, that kind of things tend to be that way as well. And so wanted to look into that and run that example as well, just to contrast to what we did yesterday and today. I'll do the same thing, just import this file, the Excel. I don't know what do I call that. All data. I'm very original how I name my files. It's probably not very good, but okay. I'll call this all data again. Make sure you don't get confused with the data you already have there. That seems okay. Go to library, make sure the data is there. It's the old one. I don't want this. Okay, so it's here. Actually, I haven't sorted these or anything yet. Let's see. I still have the desktop version, so I don't. Okay, everything looks okay. Okay, it's not working. Okay, so my variable names problems. Right? Let me send you a new version there just to make sure. Okay, so the code I have here is using this upper part is using the desktop version. So those of you using the desktop version, you can still use that, but we don't need these on the studio because we already have it in our library. There's the data. Okay, so we don't need to import the data essentially. So I'm just going to delete these. We'll run this here. Sort, sure, everything looks okay. And then this is the same, essentially the same code. What I did here is just, I mean, we can run this in many different ways, but class, again, we have treatment, we have texture, replication, and day as a factors. The color informing units, the main effects are treatments and day, and random effect rep within texture, okay? It's a little bit more complex interactions, and we do have a random factor also. And again, a lot of these will change depending on your experiment and how you interpret these. And we talked a little bit about this yesterday, what's fixed, what's random, okay? And here I'm first run of these is going to, I'm just gonna run it with a default, which basically is assuming that it's a normal distributed data. Is the output. Got all the estimates, you know, LS means, mean separations, the p-value for each of the factors, treatment day, treatment by day, all of that looks good, right? However, if you look at the performance of the model, you start to see some really strange things. It's very different from what I showed you earlier in the previous example. Look at the data distribution. I think it's pretty clear this is not normal distributed, right? Residuals, look at your distribution of residuals. As you can see, one of the things that's very clear is that the frequency, number of values that you have, low values are, there's a lot of those, and there's a long tail, which is basically what you're seeing here. That's very typical of log normal distribution data, okay? So this looks bad. However, one thing that I wanted to emphasize here is that SAS still give you an output. You still get your p-values, everything is here, you can have nice tables, but is this really correct? And so this going back to using the prog univariate, checking for normality, checking for all of those kind of things is always a good idea. Or you can basically request this in prog GLM. In this case, I requested the prog residual panel, or you can just include all plots like what we did in the previous code. So in this case, here's where in the model, we can basically choose the distribution. And in this case, I'm using a log normal distribution. So let's run this again. See what happens. The model looks much better, right? And this is also something that, you know, we talked a little bit about some of the statistics we can use for checking the models yesterday, the archaic information criterion, all of this table here, okay? And let's look at that. See, this is 5, 4, 5. Let's see how they compare. Remember the number we have with the previous model was 545. This we have almost 9,000. Okay, so definitely the second model is much smaller. So this is going back to the question yesterday also, how we compare the model. Yes, we need to use these statistics as a tool. We have again the graphs that tell us how the data behaves. We can compare the model that way and make sure we're using the model that is correct. And then this can be a little bit tricky. I usually, and you know, we're all obviously more familiar, you are familiar with your own data, and you know the type of data you're dealing with. And so we pretty much recognize what kind of data tends to be non-normal and what kind of data is normal. And oftentimes, I think that's one of the things we can we are familiar with that, and we can go with the default if we know it's normal distributed data in things like these, again, like colony forming units for bacteria, for gas emissions, runoff. All of those are pretty much well known that they are not normal distributed. Any questions, comments so far? One thing that is also one place where it's very clear when you have non-normal distributed data and you run it something as normal distributed data is in the confidence interval. And this typically what happens when you're running the data, assuming it's normal, then usually the confidence interval is going to be the same, basically the upper and lower. Okay. In this case, usually what happens is that the upper tends to be higher than the lower. So your average, your brackets confidence interval basically has a different shape. And so those are things that's very clear when you have a non-normal distributed data, and if you are using, again, things like log normal distribution. Suddenly your confidence interval is no longer the bell shape, but it's a sort of a long tail, right? Which is the log normal. Okay, any comments, questions on this or anything else that we discussed so far?
Dorvar, could you go back to the code page? I think you might have made a change and I was doing something else. And I see exactly what I needed now.
The alpha.
It was something else. It was one of those things in SAS, like a stray semicolon. So we were good. Thank you.
Okay. Yeah. Is any of you think that you're dealing with non-normal distributed data in your study, in your project? Well, that's good. Everybody's just easy data then. But anyways, I think this is one of the things that we talked about yesterday, where clean mix give you a lot of flexibility. You can go from very basic analysis to more complex analysis, and you have all the options there. So that's why I usually say use clean mix. There's no reason to use something else. Prog mix obviously kind of take care of you. You know you're not going to deal with non-normal data, then prog mix may be okay. And it's very similar. All the codes, everything is very similar between clean mix and prog mix. And so I think that's an option as well. That's up to you. You can go with either one.
I'd say many people probably aren't certain whether or not they are going to have non-normal data or not. So this is very helpful to know when we eventually will encounter non-normal data that we need to get analyzed. So useful.
Yeah. That's a good point. And I guess at this point I tend to kind of know what kind of data may be non-normal, but this is after, certainly when I was a graduate student, I had no idea. And the way I learned is that I did have a project looking at runoff of phosphorus from rainfall simulation. And my data was really a mess. And then finally I realized it was non-normal, and that's how I learned. And so I can see that, you know, at this point in your project, you may not be aware of what kind of data you're dealing with. But after I've been around for a few years, and I kind of suspecting what kind of data would be non-normal. But it is important, and it makes a difference in your results. And so I think that kind of thing is something to pay attention to. Okay, we're almost getting to about an hour. I wanted to leave plenty of time for questions, and maybe more specific to some of your studies. One thing, and I don't know what Josefina is thinking, but one of the things that seems to me like still a challenge with is generating those tables with mean separation using letters, for example. And I know there's a way to do it. Now, I don't know if we can replicate this necessarily what we are getting in SAS, if we can replicate that in R. That's maybe one thing that could be interesting to compare the different software and see what we're getting. But I still kind of struggle a little bit with R on that aspect. I'm not completely comfortable with what the output that we're getting.
So
and maybe
I
it's
have a
just
question,
me.
Dr. Dorivar.
Hmm?
I have a question.
Okay.
So if we have a like non-normal data, so how we can then fix it? Like other than, is there in like only transformations option, or how we can fix that?
Yes, and that's an excellent point. And typically, traditionally, we say we need to transform the data, right? And so we may be doing a log normal transformation of the data. We analyze using things like GLM or prop mix. The problem with that is that you're basically dealing with transformed data. So interpreting that data, the output becomes pretty difficult, right? Because it's no longer your original measurement that you're using. And so that's where the clean mix, I think, is useful, because in this case, you can specify what kind of distribution you have. Now, the challenge here is going to be what kind of distribution you're dealing with. That's going to be the challenge for you. You're going to have to determine what kind of data distribution you have. I would say so far what I'm seeing in the type of data we deal with tends to be more often log normal, which is this very high and then a long tail. That tends to be the most common one. Obviously, there are other distributions, but I haven't really worked with any other distribution because I don't see the need for it. But that would be the most common, I would say. And so again, typically in the past, what we do is transform the data, run ANOVA, and then oftentimes we kind of back transform again at the end to be able to interpret the information. But essentially with the clean mix, we don't need to do that.
Okay, thank you.
Yeah, for what you said before about the mean differences with the letters, I know there is a way. It's just not as straightforward as in SAS, I believe. And I actually never compared both results that they're exactly the same, but I think that's something that could be done.
Yeah, and I haven't spent too much time on this, Josefina, but I tried maybe one time and the results were not the same. And so I feel like the way R is calculating, at least with some of what I was able to find, is different. So I don't know, it may be just something to for a smaller group, whoever is interested to see the differences, maybe to do this. I would be glad to do that in another session. a lot of these things is, especially for ANOVA, is pretty easy with SAS. Regression seems to me like R is pretty easy compared to SAS. In SAS, especially the things like quadratic plateau, linear plateau is a little bit more complex in SAS. So that's another session that I think will be interesting, is to look at the regression component, which obviously a lot of people we may be doing, response to fertilizer or any other inputs. So
Yeah, that would be really useful. I know I've seen a lot of the output that others have been able to get through R, and I'm curious about how we go about doing that same sort of thing in SAS. Of course, the thing I was just thinking about in SAS is I get outputs that I can't use immediately. In the case of, for example, in a regression output or something of that nature. And so another good discussion we might have at some point is, so if you're using SAS, you're not using R, you're doing these sorts of things, what are you then having to do after the fact to create a figure that's ready for the manuscript?
That's an excellent point. And for regression in particular, in the case of SAS, I feel like that has been the challenge, that you need to get the output, and oftentimes you need to create a graph, for example, in Sigma plot or something like that. You need to modify, create some dummy variables, that kind of things. You can do it, but it's not very straightforward. I think in R is a little bit easier on the regression side. Also for graphs in R, it seems to be pretty powerful.
That is for sure. Pros and cons both ways.
Yes, and this is maybe I think it's probably placed for both. And I personally, I obviously use more SAS, but in some cases I'm seeing that some things are easier to do with R. So for many of you, I think it may be the situation that you use both. And actually, a couple of my recent students graduated last year. I know one of them was using only SAS. The other one was using a combination of SAS and R, depending on what's needed. And I think that's okay. It would be nice to be able to do everything in one software, which maybe we'll get there at some point with R. But the reality is, for example, for graph, I personally use Sigma plot, and there are other software out there. And so maybe in reality, we will be using a combination of 2 or 3 different software. Okay, so I think I'll stop there since we have an hour, and I think what I'd like to maybe just leave you thinking about what other options, what things you may like to see, and maybe even have a question session. I'll be willing to do that as well. I show a lot of things today, but maybe you think about some questions. So if you have your specific data, I'll be glad to look at it either separately in person, or if you want to share with the rest of the graduate students as well, I'll be glad to do that. And maybe even doing that comparison of SAS versus R, which actually I'm interested in doing that just for my learning.
Yeah, you can email either Dr. Ruiz-Diaz or myself, and I'll let him know. And yeah, I'll keep you up to date if we do we're gonna do it for sure, because I think it's quite interesting to see that difference. I believe there must be a way to get the same result. It's just that there's probably some default options that need to be changed in order to get the same result. And it's important to make sure that we know exactly which model we're fitting, and in that way, you could use either SAS or R, it doesn't matter. But
Yeah, and that's been a little bit of my challenge, I think, with R, is that I want to make sure I know what the
Mhm.
model is. And
Yes.
sometimes I see some students getting outputs and getting the output and you're happy with it, but is that really the model that we want?
Mhm.
And so I think understanding the model component, and maybe that's going a little bit more on the theory, is something that's very important. Because
Yeah.
remember, this is just a software. You still have to
Mhm.
understand statistics. And
Yeah.
that's something that you have to keep in mind, understanding the theory and then using the software as a tool.
Okay, we'll keep you up. We'll send an email in the AGSA email list
Okay,
and let you know.
Thank
Thank
you
you
all.
very much, Dr. Ruiz Diaz, and thank you all for attending.
Okay.